quite cover this the way that some people do. Some people actually have you go through all the algebraic stuff that you know and then write down what you know about the graph. We're going to actually graph first, and then we're going to write down what we know about the graph based on what we've learned. And so first of all, what we're going to do is we're looking for like intercepts. So when you graph that, you should get something like what I have up here. So I'm looking for intercepts. So where does it intersect? And so what do you notice?
Well, there's
Three.
an x-intercept right there.
There's a y-intercept here, right? What are the coordinates of that?
0,
5, 4.5.
Yeah, it's 4.5.
It is 4.5?
Yeah.
Yep.
Are you sure?
Yes.
Okay. So then what you're going to do is you're also going to do like x-intercepts. Where do those occur?
3.
Plus and minus 3. Okay. So you're going to have to write those on your graph as you write that in. The other thing you notice is that the graph is doing what here?
Decreasing.
Decreasing. So it's decreasing here. It's doing what here?
Decreasing,
Decreasing it is.
increasing,
And then
and
increasing. So do I have any special points?
Negative.
Like when I say special points, I'm looking for extreme. Do I have any extreme values?
No.
Really?
No.
Are you sure? I think I have an extreme value here, a minimum. Okay. What do I know about this right here? This is concave what? Down. What is this? Down. What is this? Concave up. So when you graph these, you're going to have to be pretty detailed. And so if you notice, that's what I'm going to expect. Okay?
That's what we write for our answer.
That is what you would write for your answer.
-9.
So we'll have to include like decreasing, increasing, conquer.
You don't need to do the increasing and decreasing. We were just talking about that.
Okay.
But what I expect in your answers is I expect what you see over there on the right. Okay? I expect something detailed. Now, you don't necessarily have to say, write horizontal asymptote. You could write like H, ASYMP. Okay? And just have the dashed lines there. But that's what I would expect in that graph. So basically what's happening is you're taking the graph that you see on your screen and you're having to kind of adapt what you know to that graph. Now we could go through and calculate all those algebraically, but I think you can look at the graph and do that without.
If it's not, if you can't cover the graph, then what do we do?
Then you'll probably have to
Oh,
do
yeah.
something algebraically.
It's like how we
Yeah. I mean, if it shouldn't be like that. At least the ones I've assigned you, I don't believe there's any weird instances. And if they are, come see me and we'll figure something out. Okay? So that's what you're going to be doing. So today's going to be just kind of looking at the graphs and inferring what.
We're done?
No, we've got a few more we're going to look at just to make sure. So let's go ahead and look at this one. Okay? So you notice there, what do you notice that you're going to have? Notice you have a vertical what? Asymptote. You also have a slant asymptote, but we haven't talked about those, so I'm not going to make you go ahead and do that. Okay? But there you go. This is what I'm looking for.
I see the slanted asymptote.
Yep. The slant asymptote is actually located along the line y equals x. And it has to do with that limit stuff that we talked about on Friday. So, okay. But that's what I would expect you to have. So on that one, you've got to have the vertical asymptote along with the relative min and the relative max.
Theater.
Okay, so that's what you need to have. Okay, so let's go ahead and look at another one. Okay. So are we ready to look at another graph? So here we go. So this one, what do you think you're going to have based on what you see right here?
We're gonna have two horizontal asymptotes.
Two horizontal asymptotes, yep.
We will have a concave up and concave down. But we don't need that.
Point of inflection.
Yes, you do have an inflection point.
So inflection here, right?
Okay, you don't have a min or a max here, but you actually do have a point of inflection. which is right there at 0, 0. Okay, so that's all you're going to have to graph. Okay, so you have your asymptotes, any min or max, any points of inflection, things like that. So pretty straightforward.
Straight as a very
So what we're going to do is we're going to go ahead and look at one more, and then that's it for today. Okay, that's all we're doing. We will get into like differentials tomorrow and some optimization problems tomorrow as well. And then you will have an assignment, another activity. I'm going to give it to you like Thursday, and it'll be due like Monday or Tuesday, and you actually have to build a model.
We Play-Doh?
Well, I never even thought Play-Doh probably would work. Analyze and sketch the graph of this. So let's just basically look here. Does it look like I've got any asymptotes based on that graph?
You have to say no. We do
No.
have a min,
You have a min, okay?
and
So it would-
inflection point.
And what would this be?
Max.
Max.
Oh, yeah.
So you'd have a max here. You'd have a min here. Your point of inflection is actually going to be somewhere halfway in between there.
We have to put that out.
So there would be your inflection points.
We
And so,
have to make
Seat
it.
graphs.
so that's all you're going to have to do. So just make a detailed graph. I want to see exact points it goes through. Okay, it should be pretty straightforward. It's not going to be that difficult of an assignment for you. Page 215, you need to do 1 through 4, and then 7 through 15, the odds. Okay, so 1 through 4, 7 through 15, the odds. If you want to use graph paper, that's fine. If you don't want to use graph paper, just use notebook paper, that's fine as well.